All right, strap in, everyone, because today we're tackling some seriously out there ideas about time. You know, that thing we always seem to need more of? Well, get ready to see it in a whole new way, maybe even through a sieve. We're doing a deep dive on some excerpts from a document. It's called Sieve by Z.T. Tosha, and it might just challenge everything you thought you knew about time.
It's amazing how Toda mixes like everyday physics with these really far out concepts. Like he starts off with this idea of a pendulum swinging back and forth and gradually losing energy,
Right?
which, in physics is a classic example of damping. Basically, the pendulum swings get smaller and smaller because of things like friction and air resistance.
Yeah, that's easy to picture. We've all seen like a swing slowly come to a stop. But then Tosha, he throws in this curveball, this concept of undamped oscillations. So systems that theoretically would just keep vibrating forever. It sounds a little, I don't know, science fiction-y, right?
It does, but think about it like this. What if there was a way to get rid of all friction, all resistance?
Okay.
In that, perfectly ideal scenario, you can have a system where the energy is perfectly conserved, perpetual motion. Of course, we know in the real world, perpetual motion machines, they're impossible. But Tosha uses this concept kind of as a springboard to ask some really big questions about the universe.
Okay, so I'm hooked already. So is Tosha saying there are like these magic undamped systems just out there in the universe, like humming along since the Big Bang?
Well, not exactly. It's more like he's using this idea of undamped oscillations to challenge how we think about energy and time. Like what if instead of time just being this straight line, marching forward, what if we thought about the possibility of cycles and rhythms like on a cosmic scale?
Okay.
Could these undamped oscillations be like echoes of the universe's creation still reverberating through space and time?
Okay, yeah, that's mind-blowing. And this is where Tosha throws in that time as a membrane thing, right? Honestly, that's the part that had me. I was super curious, but also super confused.
I get it. It's a real head scratcher. But to make sense of it, we got to tackle another one of those tricky concepts, ether. Now, the old idea of ether, like this invisible stuff that light supposedly traveled through, that's been pretty much tossed out in modern physics, right?
Yeah.
Einstein's relativity showed us we don't need ether to explain how light works.
Right, right. Vaguely remember that from physics class, yeah. So why is Tosha bringing back this outdated idea? Is he saying like we got it all wrong?
No, not exactly. It's more like he's taking the word ether and using it, well, metaphorically. So instead of like a literal substance, he seems to be talking about something more like the very fabric of space-time itself. Or maybe the quantum vacuum, that sea of virtual particles that are constantly popping in and out of existence. It's like he's giving us a new way to imagine the fundamental stuff of the universe.
Okay, so ether is this metaphorical like stuff that makes up reality. But then where does time, like as a membrane, fit into this whole thing? Is time actually doing something? Like not just ticking away in the background?
That's what he's getting at. And that's where it gets really interesting because Tosha's argument is that time, with its like inherent vibrations, it acts as a filter on this ether. He uses the analogy of a sieve, like separating out coarse material from finer material.
Yeah, yeah.
In Tosha's view, time is separating out energy into these different forms that we experience. Mass and light.
Hold it. So you're saying time isn't just a way to measure how long things take. It's actually shaping the universe, determining what becomes like physical stuff and what becomes light.
Yeah, that's the core of his argument. And honestly, it's a pretty bold idea even for someone, deep into theoretical physics. It really makes us rethink our most basic assumptions about time and its role in the universe.
Okay, yeah, you got me intrigued, but also a little skeptical. I mean, telling time a membrane, isn't that a bit of a stretch? And how does any of this connect to, like, the physics we actually know and understand?
Those are great questions. And to get to the bottom of them, I think we need to dig into how Toda tries to connect these wild ideas to some actual scientific concepts. He makes some pretty interesting links to things like symmetry breaking and the behavior of quantum fields.
Okay, you've definitely piqued my curiosity. Let's dive into those connections.
So to see how Tosha connects this time as a sieve idea to real physics, we need to unpack a couple of key concepts. First, symmetry breaking. Imagine like the very early universe. just after the Big Bang.
Okay.
Everything's incredibly hot and dense, and the forces that control the universe, gravity, electromagnetism, strong and weak forces, they're all kind of blended together, one super force.
Okay, I'm picturing this super hot, super dense soup of energy. But how do we get from that uniform state to the universe we see today with all its diversity and complexity?
That's where symmetry breaking comes in. As the universe expands and cools, that initial symmetry, it starts to break down. It's like, imagine like a perfectly smooth bubble of dough.
Okay.
As it cools, it suddenly develops like cracks and folds. That unified superforce splits into the distinct forces we know today. Different kinds of particles, they pop up.
So it's like the universe goes through a phase transition, like water freezing into ice.
Exactly. And Tosha's suggestion is that the vibrations of time that Sieve we were talking about could be what's driving this symmetry breaking. It's almost like time is acting as a cosmic sculptor, shaping those fundamental building blocks of the universe.
Okay, that's a really cool idea, but I gotta admit, it still feels kind of abstract. How do those time vibrations actually like cause symmetry breaking? Is there a way to visualize this?
Well, Tosha tries to get a little more visual, when he brings in some actual mathematical functions to represent different ways of conceiving time. He shows us two different graphs. One is a rational function, which has this sudden break in it, what mathematicians call an asymptote. And then there's a smoothly oscillating but decaying sine wave. Believe it or not, these graphs show two very different ways of thinking about time.
I'm seeing the graphs in my head, but honestly, math is not really my strong suit. So could you break it down for me? What do these graphs like actually tell us about time?
Okay, so the rational function with that sudden break or jump that represents a linear view of time, but with the possibility of these discontinuities. Think of it like a timeline.
Okay.
But there are certain points where time itself might break down or jump ahead.
So like black holes. Those regions of space-time where gravity is so strong that even light can't get out.
Exactly. Black holes they're a great example because they're, these areas where our current understanding of physics kind of breaks down. Time might behave really differently there, maybe even coming to a standstill or even looping back on itself. And then we have the nonlinear function, the sine wave, right? That represents a more cyclical view of time. It's about ebb and flow. Expansion and contraction, a continuous process with no real beginning or end.
So that sounds a lot like some of those ancient philosophies that see time as a repeating cycle of creation and destruction. It's like the universe is breathing in and out, constantly renewing itself.
Precisely. And what's fascinating is that Tosha doesn't just, leave it at these abstract graphs. He actually connects those mathematical functions to specific cultural perspectives on time.
Wait, are you saying like our understanding of time is influenced by our culture? That sounds a bit, I don't know, subjective.
Yeah, it might seem that way at first, but Tosha, he makes a pretty strong case. He argues that Western thought, with its emphasis on like linear progress and having a clear distinction between past, present, and future, that's much more aligned with that rational function. Time as a straight line, maybe with a few bumps along the way.
Yeah, I can see that. Like how we think of history as this timeline or that Judeo-Christian idea of time going from like creation to an apocalypse. It's all about moving forward, even if it's towards an eventual end.
Exactly. But then Tosha contrasts this with, Eastern philosophies, which tend to emphasize cyclical time, the eternal dance of existence, this constant back and forth between creation and destruction with no real beginning or end. And this view, it aligns much more with that oscillating sine wave, that continuous flow of energy and transformation.
I've always been drawn to those cyclical views of time. They feel, I don't know, more hopeful, more in tune with the rhythms of nature. But I'm curious, does he see these cultural perspectives as just different ways of interpreting the same reality? Or does he think they actually reflect different underlying truths about the universe?
That's a fantastic question, and it really gets to the core of one of the biggest debates in both physics and philosophy. Is the universe fundamentally deterministic, meaning everything is kind of preordained, or is there actual randomness and free will at play?
Whoa, okay, that's a heavy question. I'm not sure I'm ready to tackle the meaning of free will just yet. But I am curious to explore how Tosha connects these cultural views of time back to like actual scientific concepts. You mentioned quantum fields earlier.
Right. This is where Tosha's ideas get really interesting because he starts to bridge the gap between, ancient wisdom traditions and modern physics. He points to things like wave-particle duality and the behavior of quantum fields as potential examples of how this Eastern cyclical view of time might actually be reflected in the very fabric of reality.
Okay, now you're speaking my language. Break it down for me. How does quantum physics connect to these ancient ideas about cyclical time?
Well, let's start with wave-particle duality. It's this mind-blowing idea that light, it can act like both a wave and a particle depending on how you observe it. It's like the universe can't quite make up its mind.
Yeah.
And this fundamental uncertainty, this fluidity, it's really in tune with those Eastern philosophies that see time as constantly changing, a dance of creation and destruction.
It's like the universe is saying, I'm not bound by your rigid categories of neither or. I'm both and neither all at once.
Exactly. And then there's this whole concept of quantum fields, right? They're fundamental wave-like entities that permeate all of space-time. And then they give rise to particles. They're always fluctuating, interacting, creating, destroying particles in this net-ending dance. It's a very dynamic and fluid picture of reality, much more aligned with that oscillating sine wave than a rigid linear timeline.
So we're seeing these really fascinating parallels between these ancient wisdom traditions and modern science. It's like they're approaching the same mysteries from different angles, but coming to some surprisingly similar conclusions about the nature of time.
And that's what makes Tosha's work so thought-provoking. It forces us to step outside of our usual ways of thinking and consider some alternative perspectives. It's a reminder that our understanding of the universe is always evolving. There's still so much we don't know.
This whole deep dive has been a wild ride. I feel like we've gone from like the familiar world of swinging pendulums to the mind-bending edges of theoretical physics and cosmology, and then landed somewhere in the realm of ancient wisdom and spiritual insights. But before we get too lost in the philosophical weeds here, I want to bring it back to Tosha's central metaphor. Time is a sieve. We've talked about how this sieve might be separating mass and light, but how does that actually like work? What's the mechanism behind this cosmic sorting process?
That's the million-dollar question, isn't it? And unfortunately, Tosha doesn't give us a clear-cut answer, but he does offer a few intriguing hints, possibilities that are worth exploring. One idea is that the vibrations of time, they create these patterns, almost like ripples in a pond,
Okay.
and those patterns determine how energy comes together, either into particles, the stuff that makes up matter, or waves, which we experience as light.
Okay, so it's not just about separating mass and light. It's about actually shaping them, giving them their specific properties. Time as a cosmic sculptor.
That's a great way to put it. It's almost like time is the artist and the universe is the canvas. And those time vibrations, they're the brush strokes that create this masterpiece we call reality.
That's a beautiful image. But I got to ask, does any of this actually line up with what we know about physics, or is this all just really cool speculation?
Well, it's definitely on the edge of theoretical physics, but there are some interesting connections. We already talked about symmetry breaking in the early universe. How Tosha suggests that time vibrations could be the driving force behind that process.
Right. And you mentioned that there are also some connections to quantum field theory.
Exactly. In quantum field theory, particles they're seen as excitations of these underlying fields, kind of like ripples on a pond.
Uh-huh.
And the behavior of those fields is governed by something called time evolution. So you can see how Tosha's idea of time as this dynamic force, constantly shaping and reshaping the quantum landscape might fit into that framework.
It's amazing to think that some of our most advanced scientific theories might actually be hinting at a much deeper, more interconnected view of the universe, one where time isn't just a passive background, but an active participant in this cosmic dance.
And that's the beauty of exploring these kinds of ideas. Even if they turn out not to be scientifically accurate in every detail, they can still spark our imaginations and open up new ways of thinking about the universe and our place within it.
This deep dive has definitely done that for me. I'm walking away with a whole new appreciation for the mystery and wonder of time. It's not just about minutes and hours, clocks and calendars. It might be the very force that shapes our reality.
And that's a powerful thought to carry with us. It invites us to really pay attention to time's flow in our own lives, to see how it shapes our experiences, our relationships, our very sense of self. But there's one more fascinating aspect of Tosha's Sieve document that we need to explore. His really interesting connections between specific mathematical functions and the different ways Western and Eastern cultures have traditionally viewed time.
Okay, now you're really speaking my language. I love how this deep dive keeps weaving together science and philosophy and culture. Let's break down those connections. All right, so we've covered so much ground here, from swinging pendulums to quantum fields. And it seems like Tosha's really building this case that time is so much more than just a way to measure how long things take. But I gotta admit, I'm still kind of struggling with this central metaphor of time as a sieve. What exactly is time filtering, and how does this connect to those mathematical functions we were talking about earlier?
This is where Tosha really pushes us to think outside the box. Remember how we were discussing ether and how he's using it metaphorically, to represent that fundamental stuff of the universe. Maybe it's the fabric of space-time itself, or maybe it's that quantum vacuum, that sea of virtual particles constantly popping in and out of existence.
Right. Yeah, like the raw potential. Everything emerges from that.
Exactly. So Tosha's argument is that time, with with its inherent vibrations or oscillation, it acts like a sieve on this ether, and it's separating it into the different forms of energy that we experience. Mass and light. Imagine like shaking a sieve, right? And it's filled with sand and pebbles. The smaller grains of sand, they fall through the holes, right? But the larger pebbles, those get left behind.
Okay, yeah, I can picture that. So is time like the sieve, and the ether is kind of like the sand and pebbles, but then how does time actually like shake the ether?
Well, that's where those mathematical functions come back in. Remember the rational function, the one with the sharp break that Tosha links to the Western, the linear view of time. He suggests that this abrupt break, it could represent a kind of like filtering or separation point.
So it's like time is moving along this straight line, and then suddenly, bam, something gets separated out.
That's one way to think about it, yeah. And Tosha suggests that what gets separated out at these points of discontinuity could be the heavier elements of the ether, the stuff that eventually forms into matter, into particle.
Okay, yeah, that's starting to make a little more sense. But what about the sine wave, the one that represents the cyclical view of time? How does that fit into this whole sieve metaphor?
Well, with the sine wave, Tosha, he focuses on those continuous oscillations, the ebb and flow of the wave, and he suggests that these oscillations could represent a more like gradual and rhythmic filtering process. Imagine, the sieve gently vibrating, so it causes the finer sand to slowly pass through, while the bigger pebbles are held back.
So in this view, time isn't just separating mass and light. It's also kind of shaping them, influencing their properties as they come out of the ether.
Exactly. It's a lot more dynamic, a lot more nuanced than just a simple separation, right? It's almost like time is like a composer, and it's creating a symphony of vibrations. And those vibrations give rise to all the different forms of energy and matter that we see in the universe.
That's such a beautiful analogy. But I got to be honest, it's still really hard to wrap my head around how any of this actually works. Well, on a visible level, is there any scientific evidence to support these ideas? Or is this all just really cool speculation?
Well, like we discussed earlier, there are some pretty intriguing connections to to concepts in modern physics, like symmetry breaking and how quantum fields behave. But to be fair, Tosha's ideas are they're really pushing the boundaries of what we currently understand about the universe. He's proposing a really radical new way to think about time, and it's going to take a lot more research, a lot more exploration to really determine if there's any scientific validity to what he's saying.
So you're saying we shouldn't take Tosha's ideas as like the absolute truth, but rather as a really thought-provoking challenge to how we currently understand the universe.
Exactly. I think Tosha himself would agree with that. He's not claiming to have all the answers, but he's asking some really important questions, questions that could lead to some really groundbreaking discoveries in the future. He's encouraging us to really stretch our imaginations, to consider possibilities that might seem a little out there at first, but they could ultimately lead us to a deeper understanding of the cosmos.
I think that's a great takeaway from this whole deep dive. Tosha's Sieve document. It's a reminder that the exploration of time is nowhere near finished. There are still so many mysteries to unravel, so many questions to ask. And who knows, maybe one day we'll actually be able to test some of Tosha's ideas and see if they hold up to scientific scrutiny.
And even if we don't find, definitive proof, the journey of exploration itself is so incredibly valuable, right? It forces us to think critically, to question what we think we know, and to just stay open to new possibilities.
I couldn't agree more. So to all you deep divers out there, keep questioning, keep exploring, and keep that sense of wonder alive. We may not have all the answers about time, but that doesn't mean we should stop searching for them. So until next time, keep diving deep.